Hello students, today we will discuss a chapter of general chemistry which is bonding, chemical bonding. Now here's the chemical bonding. So first of all, why the atom forms chemical bond, or for the existence of molecule, we have two different theory. One is most classical, which is known as Octet rule theory. According to Octet rule, every atom have tendency to gain the outermost configuration of a nearest inert gas or to complete its octet or duplet. But Octet rule theory is not an overall theory for the existence of molecules, since so many molecules are known which are electron deficient as well as electron rich molecules like PCl5, SF4, SF6. These molecules could not explain by the Octet rule theory. So for the existence of molecule, most advanced theory which is known as valence bond theory is introduced. According to valence bond theory, every atom have tendency to pair its electron present either in ground state or in excited state. The molecule which follows or satisfied Octet rule as well as the molecule which doesn't obey Octet rule, both are explained by valence bond theory. So firstly we will discuss about the valence bond theory, VB theory. So according to valence bond theory, every atom have tendency to pair its electron with the help of another electron of different atoms. Either these electrons are present, unpaired electrons are present in its ground state or in its excited state. Suppose we have an example like nitrogen as well as phosphorus. Here's the atomic number of nitrogen is 7 and the atomic number of phosphorus is 15. Now write the electronic configuration of both element. In case of nitrogen we have 1s2, 2s2, 2p3, 2 to 4 or 3, 7. While in case of phosphorus it will be 1s2, 2s2, 2p6, 3s2, 3p3. Now in case of nitrogen we have, here is the 2s orbital which contain 2 electrons, and in 2p subshell we have 3 electrons, all 3 are unpaired. This is the ground state. Similarly, in case of phosphorus, here is 3s box in which 2 electrons, and here is 3p which contain 3 electrons, all 3 are unpaired, which is also ground state. So in ground state of nitrogen and phosphorus, both contains 3 unpaired electrons. So according to VB theory, to gain the stability, these unpaired electrons should be paired with the help of 3 different atoms. Like if these electrons are paired with the help of chlorine electron, with the help of sharing of 1 electron with each chlorine atom, then a molecule is formed which is NCl3. Similarly, in case of phosphorus, with the help of 3 chlorine atom, all 3 unpaired electrons are paired, and here is PCl3 is formed. So NCl3 as well as PCl3 both are formed in ground state of nitrogen and phosphorus respectively. In case of nitrogen, here is 2s as well as 2p. It means second shell is the outermost shell, and if n is equal to 2, principal quantum number is 2, then the possibility of L are 0 as well as 1. So we have S as well as P only. We have two subshell, S and P. No further subshells are vacant. But in case of phosphorus, here the principal quantum number n is equal to 3. Last, the outermost shell is third shell, and third shell contain, we have three subshells, since the value of L will be 0, 1 as well as 2. So S, P as well as D also. So in case of phosphorus, D subshell is vacant, in which 5 orbitals. And if phosphorus absorb the energy from outer source, then its 3s electron jumps from 3s to vacant 3d orbital, which is known as excited state. So first excited state of phosphorus contains 5 unpaired electrons. This 3s electron jumps into 3d. So we have how many unpaired electrons? 1, 2, 3, 4 as well as 5. So how many chlorine atoms are required to pair all unpaired electrons of phosphorus? 5 chlorine atoms are required. So in case of first excited state, PCl5 is formed. Clear? So while in case of nitrogen, due to absence of vacant D subshell, the excited state is not possible, so NCl5 does not exist. PCl5, which is formed in excited state of phosphorus, first excited state of phosphorus, so PCl5 doesn't obey octet rule, since it is electron rich molecules, while NCl3 as well as PCl3 both obey octet rule, since both are formed in ground state of atom. Clear? So this is the valence bond theory for the existence of molecule. Once again, firstly, according to VB theory, every atom have tendency to pair its electron present either in ground state or in excited state. For example, nitrogen and phosphorus both contains 3 unpaired electrons in ground state. So in ground state, with the help of 3 chlorine atom, all 3 electrons are paired and NCl3 is formed as well as PCl3 is formed in ground state of nitrogen and phosphorus. But due to presence of vacant D subshell in case of phosphorus, the first excited state contains 5 unpaired electron. Due to 3s electron jumps from s orbital to vacant d orbital after absorption of energy from outer source. So 5 unpaired electrons are present in first excited state of phosphorus. So PCl5 is formed in first excited state of phosphorus. But in case of nitrogen, due to absence of vacant D subshell, the excited state is not possible. So NCl5 does not exist. Is it clear? So this is the theory, valence bond theory, and with the help of valence bond theory, we can easily check the existence of molecule. Suppose if a question is asked, which of the molecule exists according to VB theory? Which of the following molecule exists according to VB theory? Suppose here is the question, existence of molecule by using valence bond theory. Molecules are like SF2, OF2, SF4, OF4. For the existence of molecule, firstly, here is the central atom is oxygen as well as sulfur. Both are in same group. Here is O and here is S. The atomic number of oxygen is 6 and sulfur will be 16. So electronic configuration of oxygen, it is 1s2, 2s2, 2p4. But in case of sulfur we have 1s2, 2s2, 2p6, 3s2, 3p4. So here is the orbital diagram. 2s box in which 2 electrons, 2p box 1, 2, 3, 4 electrons. Clear? Similarly, in case of sulfur, here is 3s box which contain 2 electrons and 3p which contains 4 electrons, 3p. Simply due to third shell, d orbital is vacant in case of sulfur, but here is absent due to second shell. Second shell contains only 2 subshell, s as well as p. Clear? So in ground state, both oxygen as well as sulfur contains 2 unpaired electrons. So with the help of 2 fluorine atom, these unpaired electron will be paired, and here is formed OF2 as well as SF2 also in ground state. Clear? So OF2 and SF2 both are formed in ground state of sulfur as well as oxygen. Clear? But due to presence of vacant d subshell in case of sulfur, the first excited here 3p electron jumps from p to d, vacant d subshell. So we have how many unpaired electron? 1, 2, 3 as well as 4. So in case of first excited, SF4 is formed. Clear? In next excited, 3s electron jumps from s to d. So in second excited, we have 1, 2, 3, 4, 5, 6. So here is SF6 is also formed. So SF2, SF4 and SF6, all molecules exist. First SF2 exists in ground state, while SF4 as well as SF6 both exist in first as well as second excited state respectively. But in case of oxygen, due to absence of vacant d subshell, only OF2 molecule exists. OF4 and OF6 does not exist due to absence of vacant d subshell. Clear? So here answer will be SF2, SF4, OF2 also, but OF4 does not exist due to absence of d subshell in case of oxygen. Clear? Now one more question. Same question, but options are IF2, IF3, IF4, IF5. More than one options are correct. According to VB theory, which of the following interhalogens exist? So here is the central atom is iodine. Clear? And iodine, whose atomic number is 53, which is the 5th period element, so d subshell is vacant. Clear? So in case of halogen, the general configuration is NS2 NP5. Clear? So in case of iodine, if we have no idea about its atomic number, then we can write the outermost configuration with the help of general configuration of halogen group, which is NH2NP5. Clear? So here is NH2 and NP5. This is the ground state. And we can see in ground state of iodine, one electron is unpaired. Clear? So how many fluorine atoms are required? One fluorine is required to gain the stability of iodine atom. So with the help of one electron of fluorine, this electron will be paired, and here IF is formed in ground state. But due to fifth period element, here is D subshell is vacant. This is the ground state, and in first excited, this 3p electron jumps from 3p to 3d. So how many electrons are unpaired? 1, 2, 3. So how many fluorines are required? 3. So here is IF3 is formed. Clear? In second excited, this electron also jumps from p to d. So we get 5 electrons are unpaired. So IF5 is formed in second excited state of iodine. Simply, in third excited, this s electron jumps from s to d subshell. So we have 1, 2, 3, 4, 5, 6, 7. 7 are unpaired. So here is IF7 is formed. So all odd numbers of fluorine atoms are formed, like IF, IF3, IF5 as well as IF7. Clear? So here this molecule does not exist, this one exists, this does not, this one exists. IF3, IF5 are known, but IF2, IF4 doesn't exist according to VB theory. One more question. According to VB theory, question will be asked such as, what is the possible oxidation state of iodine? So possible oxidation state of iodine in case of interhalogens we have, here is +1, +3, +5 as well as +7. Even number does not exist due to absence of even number of unpaired electron. Clear? Next, same question, options are changed. Which of the following molecule exist? Options are CCl2, CCl4, SnCl2, SnCl4, PbCl2, PbCl4. Here is the 6 compounds, PbCl4. 6 compound, and this question should be integer type. How many molecules are known according to VB theory? So 0 to 9. Answer should be between 0 to 9. Clear? So what is the procedure? Firstly, select the central atom. In case of carbon, it is central, stannous, central, lead, central. All these are carbon family elements. So outermost configuration of all these elements are NH2NP2. Clear? In case of carbon or except carbon, all these atom contains D subshell, vacant D subshell. Carbon doesn't have vacant D subshell due to second period element, and if element is second period, then the principal quantum number should be 2, and if the principal quantum number is 2, then the possibilities of azimuthal quantum numbers are 0 and 1. So we have only 2 subshells as well as p. But except second period element, all element always contains vacant d subshell. Clear? So in case of carbon, here is 2 electrons are in ns as well as 2 are in np. So in ground state we have 2 unpaired electron. So CCl2 is formed in ground state. But in case of carbon, after absorption of energy, this unpaired electron jumps from s to p subshell. So here is 4 electrons are unpaired. Clear? And after excitation of ns electron, the p subshell becomes half filled, and half filled p subshell is more stable as compared to partially filled p subshell. So carbon forms compound always is in excited state, never in ground state. So CCl2 does not exist, it is unstable, since carbon, the excited state of carbon contain more stable p configuration as compared to ground state. Clear? So CCl4 is known while CCl2 does not exist, but according to VB theory, CCl2 may exist due to presence of 2 unpaired electron in ground state. But in case of tin, here is both halides are exist or known, stannous as well as stannic chloride. Both are stable, SnCl2 as well as SnCl4. And in case of lead, PbCl4 does not exist due to inert pair effect. The ns electron is surrounded by n-1d electron of lead, so it doesn't take part in excited state. So we have PbCl2 is known only, while only 2 unpaired electrons are present in ground state, and its excited state is not possible due to inert pair effect. The ns electron is surrounded by n-1d electron. Only in case of lead in carbon family it shows inert pair effect. So PbCl4 does not exist or unstable, while PbCl2 is the stable compound. So here is a point in carbon family. On moving down in the group in carbon family, remember that on moving down in the group in carbon family, the +2 oxidation state tendency increases, while +4 oxidation state tendency decreases. Clear? Why +2 oxidation state tendency increases? Reason behind, due to inert pair effect in case of lead, while in case of carbon, +2 oxidation state is less stable as compared to +4 in case of carbon. Reason is the first excited state contain half filled p configuration, which is the more stable as compared to partially filled p configuration. Clear? So here is the exception in case of carbon, remember that. Similarly, one more exception in case of noble gas also, like XCF2, XCF4, XCF6, XCF8. In case of noble, the configuration becomes NH2 NP6. All electrons are paired in ground state. That's why xenon is a noble gas or stable configuration or stable element. But only in case of xenon, after absorption of energy, this p electron jumps from p to d subshell, vacant d subshell. So in first excited, 2 electrons are unpaired, so XeF2 is formed. In next excited we have 1, 2, 3, 4 are unpaired, so XeF4 is formed. In next excited this electron also jumps from P to D, so here is XeF6 is formed. Clear? Here is the second excited, here is the third excited. But due to inert pair effect, the ns electron is surrounded by n-1d electrons of xenon. Ns electron act as inert. It doesn't take part in excited state or excitation. So XeF8 does not possible due to inert pair effect. Is it clear? So this is the valence bond theory for the existence of molecule. Now octet rule theory, which is already understood. So now the concept of bonding, to complete its octet, atoms form 3 different types of bond. One is ionic or electrovalent bond, second one is covalent bond, third is coordinate bond. Simply, electrovalent or ionic bond, the bond formed by the transfer of electron is called ionic or electrovalent bond. First, ionic bond, which is also known as electrovalent bond. Simply the bond formed by the transfer of electron. Now what is the condition to form ionic bond or electrovalent bond? There is the 3 points. First, high electron positivity. The electron losing tendency is very high, then atom prefers to form ionic bond. Second, low ionization energy. If the ionization energy is very low, then the size of atom should be large. So after transfer of electron, it forms ionic bond. And third one is bigger size of cation as well as smaller size of anion always prefers to ionic compound or ionic bond. So in case of periodic table, only S block element except second period element, all S block element like alkali metal as well as alkaline earth metals except lithium as well as beryllium always forms ionic bond. No exception is known. Clear? All S block elements except second period element always form ionic bond. For example, like NaCl or MgCl2, both are ionic. Here is alkali metal and this one is alkaline earth metal. So Na, which contain only 1 electron in the outer shell, and chlorine contains 7 electrons in the outer shell. So here sodium transfer electron from outermost shell to chlorine. So chlorine gets 1 more electron, so it gets negative charge, while due to transfer of electron of sodium it becomes positive. And due to their opposite charges, electrostatic force is act between both atoms. This force or bond is known as ionic bond. And after transfer of electron from sodium, it becomes 2,8, or it becomes the stable configuration of neon, while after gaining of 1 electron from sodium, the chlorine becomes the stable configuration of argon. Both are inert, argon as well as neon, so both are stable and they both are associated with the electrostatic force of attraction. So molecule is known as electrovalent compound or electrovalent molecule. this attraction or bonding nature is called ionic bond or electrovalent bond. Clear? Similarly, in case of magnesium, we have 2 electrons in the outermost shell, and chlorine 7 electrons in the outermost shell. We have 2 chlorines. So by the transfer of 2 electron to 2 chlorine, here is 1 electron, so it gets negative charge. Here is 1 electron, so this chlorine also gets negative charge, and magnesium gets 2 positive charge, and due to their opposite charges, all atoms are associated with each other through electrostatic attraction. So molecule is known as electrovalent bond or ionic bond. Clear? And after absorption of 1 electron from magnesium, it becomes argon, as well as magnesium is neon, and this chlorine is also argon. So all three are inerts. Inert gas stable configuration, and all three are associated with their opposite charges. So molecule is called electrovalent or ionic compound. Is it clear? Note it. Now, second is covalent bonds. Covalent bond, the bond formed by the sharing of electron. And what is the condition to form covalent bond? Then the p block elements or non-metal mutually formed covalent compounds. One p block element with another p block element always form covalent compound. Due to their smaller size, after sharing of electron, it becomes stable after gaining the stable configuration of nearest noble gas. Clear? Suppose Cl2. Chlorine contains 7 electrons in the outer shell, and here is chlorine also contains 7 electrons in the outer shell. Both required 1 electron to gain the outermost configuration of nearest noble gas, which is argon. So the electron of one chlorine is shared with the electron of another chlorine. Similarly, second one chlorine is also shared 1 electron with another chlorine. So after sharing of 1 electron with each chlorine, both chlorine becomes the stable configuration of argon. So both are stable, and such type of bond which is formed after sharing of 1 electron is known as covalent. Clear? Similarly, hydrogen, one molecule is like HCl. Hydrogen contains 1 electron in the outermost shell, and chlorine, which contains 7 electron in the outermost shell. So both required 1 electron to complete its duplet as well as octet, since the nearest noble gas of hydrogen, which is helium, outermost configuration in which 2 electrons, while the nearest noble gas with chlorine, it is argon. So both requires 1 electron. So after sharing of 1 electron, it becomes stable after gaining outermost configuration of helium in case of hydrogen, while the outermost configuration of argon in case of chlorine. Clear? This bond is known as covalent bond. In both cases, Cl2 as well as HCl, both bonds are covalent bond. But one major difference between these covalent bonds, what? Here both are chlorine, so the electronegativity of both chlorines are same. So the shared electrons are at the middle of both chlorine. Clear? But in case of HCl, the electronegativity of Cl is greater as compared to hydrogen, so shared electrons slightly shifted towards chlorine. Clear? So chlorine gets partially negative charge and hydrogen gets partially positive. Such type of covalent bond in which partial charge will be developed after the difference of electronegativity between the shared atom is known as polar covalent bond. Here is polar covalent bond. But in case of chlorine, due to absence of charges, since the both chlorines having same atom which have same electronegativity, so it is known as non-polar covalent bond. Clear? So non-polar covalent bond as well as polar covalent bond. So covalent bonds according to the difference of electronegativity are of two types. First is polar and another is non-polar. What is non-polar covalent bond? So non-polar covalent bond is when the electronegativity of both shared atoms are same, then the shared electrons are at the middle of both shared atom. Such type of molecule or bond is known as non-polar covalent bond, like Cl2, O2, H2, N2, etc. And what is polar covalent bond? When the difference of electronegativity between the atom, then the shared electron slightly shifted towards highly electronegative element like HCl. So partial charge will be developed on both atoms. Such type of covalent bond is called polar covalent bond. Is it clear? In case of polar covalent bond, molecule may shows dipole moment in case of polar covalent bond. So here is the polar as well as non-polar. Suppose we have two examples of polar covalent bond, like BCl3 or NCl3, or simple example is like CO2 as well as SO2. Clear? Carbon, which contains 4 electrons in the outermost shell, and here is oxygen, which contain 1, 2, 3, 4, 5, 6. Similarly, this one also contain 1, 2, 3, 4, 5, 6. So to complete the octet, 2 electrons are required in case of oxygen, while in case of carbon we have 4 electrons are required. So after sharing of 2 electron with one oxygen and with another oxygen, all atoms should be completed It's octet, yeah. The octet of all atoms are completed. Clear? While in case of sulfur, it is electron rich molecule, so doesn't obey octet rule, and due to presence of lone pair, bond is slightly tilted or in V shape. But in absence of lone pair in case of carbon, it is linear. Molecule is linear, and due to presence of lone pair, repulsion of lone pair, it will be V shaped or bented molecule. So here is the difference of electronegativity. Bond is polar. Since the electronegativity of oxygen is greater than carbon, so shared electron slightly shifted towards oxygen. Similarly, in case of other side, this oxygen, electronegativity of O is greater than C, so this shared electrons are shifted toward this right oxygen. Clear? But due to opposite direction, the polarity is neutralized. The polarity is neutralized. So bond is polar, but net molecule is non-polar. Here bond is polar, but molecule is non-polar. But in case of sulfur dioxide, due to the repulsion of lone pair, shared electron shifted downwardly towards oxygen. Clear? So downwardly gets partially negative charge and upwardly gets partially positive. So here is bond is polar as well as molecule is also polar. Bond and molecule both are polar. Such type of molecule which is polar shows dipole moment. But in case of carbon dioxide, the value of dipole moment is 0 since molecule is non-polar. So remember that if molecule, not bond, if molecule is polar, then it shows dipole moment. In case of CO2, bond is polar but molecule is non-polar, so it doesn't show dipole moment, or the dipole moment of CO2 is 0. Clear? Dipole moment, which is denoted by nu, and the magnitude of dipole moment, which is the charge multiplied by distance between both charges. Here is the formula of dipole moment. Distance between both opposite charges, suppose it is d, then the magnitude of charge multiplied by d is the magnitude of dipole moment. So one point, all polar bonds doesn't show dipole moment. All polar molecule shows dipole moment. Suppose, for example, in case of CO2, bond is polar but the dipole moment of CO2 is 0 due to the cancellation of polarity. But in case of sulfur dioxide, bond and molecule both are polar, so here sulfur dioxide shows dipole moment. Clear? So what is the condition? So what is the condition for dipole moment, or how will you decide the given molecule shows dipole or not? So here is the condition for dipole moment. Now condition for dipole moment. So first point is, if central atom contain, remember that first point, if central atom contains at least one lone pair, it shows dipole moment, while lone pair distorted the geometry of molecule which is responsible for the dipole moment. Suppose example is like BCl3 and NCl3. In both molecule, boron contains 3 electrons in the outermost shell and all 3 are shared with chlorine atom. All 3 are shared with chlorine atom. So central atom doesn't have any lone pair. So the dipole moment of BCl3 is 0. But in case of NCl3, here is the 5 electrons in the outermost shell and 3 are shared with chlorine. So one acts as lone pair. And if one electron acts as lone pair, so it shows dipole moment. Clear? So in case of BCl3, boron exists at the center of the triangle. If the geometry of molecule is discussed, then the boron contains at the center of the triangle. Boron is at the center of the triangle, as well as chlorine are at the corner of the triangle. So the net polarity will be cancelled out. Clear? But in case of NCl3, due to presence of lone pair, geometry will be distorted and it is converted into trigonal pyramidal like this. All sides away from lone pairs. So here is the triangle based pyramid in case of NCl3. And due to the electronegativity which is greater than chlorine, so all shared electrons shifted towards nitrogen. So nitrogen gets partially negative and chlorine gets partially positive. Here is polarity is created, so molecule shows dipole moment. Clear? So first point is, if central atom contains at least one lone pair, it shows dipole moment. One more example, like BeCl2 as well as SnCl2. BeCl2 and SnCl2. Clear? In case of beryllium, which contains only 2 electrons in the outermost shell, beryllium only 2 electrons and 2 are shared with chlorine. No lone pair is on beryllium. But in case of tin, we have 4 electrons in the outermost shell in which 2 are shared with chlorine. So one lone pair is present at Sn. Here is the lone pair. So these are chlorine, shared electrons shifted towards chlorine. Since the electronegativity of Cl is greater than B, so here is partially negative, B gets partially positive, here is partially negative, B gets partially positive. Polarity is minimized or cancelled out. So here is mu is 0. But in case of SnCl2, due to the attraction of shared electron towards Cl, chlorine gets partially negative and upwardly get partially positive charge. So polarity is created, so molecule shows dipole moment. Clear? Here bond is polar but net polarity is minimized or cancelled out or compensated. So the dipole moment of BeCl2 is 0, while in case of SnCl2, due to presence of one lone pair in case of Sn, it shows dipole moment. Next, second condition. If compound is unsymmetrical about central atom, then it shows dipole moment. Compound is unsymmetrical about central atom. Suppose we have two molecules like CCl4 and one is CHCl3. So here is carbon, all four of carbon are shared with 4 chlorine atom, and in case of chloroform, one is shared with hydrogen and left 3 are shared with chlorine atom. So here CHCl3 compound is unsymmetrical, both doesn't have any lone pair, but in case of CHCl3 it is unsymmetrical. Here is hydrogen but all sites are associated with chlorine, and here all sites are associated with chlorine, so that it is symmetrical but it is unsymmetrical. And with respect to the geometry of molecule, here is CCl4 tetrahedral, and here is also tetrahedral but one side is associated with hydrogen. Here is the dot structure. So in case of CCl4, due to attraction of shared electron towards chlorine, the dipole or polarity is nullified or neutralized, so the dipole moment of CCl4 is 0. But in case of CHCl3, due to the attraction of shared electron towards chlorine, and here electronegativity of C is greater than H, so the shared electron shifted towards carbon, so all shared electrons shifted downwardly, so downwardly gets partially negative and upwardly gets partially positive charge. So molecule shows dipole moment due to the polarity of molecule. Clear? So CCl4, the dipole moment of CCl4 is 0 due to symmetrical distribution or symmetrical arrangement of chlorine around central atom. But in case of CHCl3, due to unsymmetrical arrangement, it shows dipole moment. Now, third point. Third point is the dipole moment also depends upon bond angle. On decreasing the bond angle, the value of dipole moment increases. For example, in case of cyclo compound, we can easily compare with the help of bond angle of the group like this. Here 2 chlorine attach adjacently, 2 chlorine attach alternately, and 2 chlorine just oppositely. So the angle between these chlorine groups, here is theta 1, here is theta 2, here is theta 3. If the mu1, mu2 and mu3 are the dipole moment of first, second and third compound, due to lesser bond angle in case of first one, the dipole value is maximum, while mu2 is greater than mu3, and in case of mu3 it will be 0 due to compensation of polarity. Both chlorine attach just opposite, so the polarity is cancelled out, and the dipole moment of last molecule, which is 1,4-dichlorocyclohexane, it will be 0. Clear? So one more point on decreasing the bond angle. On decreasing the bond angle, the value of dipole moment increases. Since molecule is more unsymmetrical, and unsymmetries increases the polarity of the molecule, which increases the value of dipole moment. Clear? Now, one more point. The dipole moment of cis alkene is greater than trans in case of similar groups attachment, while in case of dissimilar group, the point is just opposite. The dipole moment of trans alkene is greater than cis alkene. Example. Suppose here is the same group attached on same sided cis-butene. Both methyls attach on same sided of double bond. This is cis. And both methyls attach on diagonally. It is in trans. Both methyls attach on same sided. So methyl, due to plus I effect, repulsion of shared electron downwardly. So downwardly gets partially negative and upwardly gets partially positive charge. And due to the polarity, molecule shows dipole moment. But in case of trans butene, polarity will be cancelled out, since methyl push the shared electron downwardly, whilst this methyl groups push the shared electron upwardly. So polarity will be cancelled and the dipole moment of trans butene is 0. Clear? But in case of dissimilar groups like chlorine as well as CH3, here is trans and here is cis. Methyl push the electron pair downwardly, but here chlorine pull the electron pair downwardly. So downwardly gets partially negative, upward gets partially positive charge. Here is the dipole moment mu1, and in case of cis, here is downwardly but here is upwardly, but these groups are not identical, so pulling and pushing are not same. So some polarity will be developed according to the difference of electronegativity. So molecule shows dipole, but the mu1 value is much more as compared to mu2 due to maximum polarity, all shared electron pushed towards downward direction. Clear? So this is the point when molecule shows dipole and when molecule doesn't shows dipole. Now the types of covalent bond according to the overlapping of orbital. It will be divided into two different ways. One is sigma covalent bond and another is pi covalent bond. So according to overlapping of orbital, covalent bonds are of two types. First is sigma covalent bond. sigma covalent bond. Sigma covalent bond, when the overlapping of orbital is according to x-axis or head-to-head or head-on overlapping, according to linear or head-on overlapping, sigma covalent bond is formed. Clear? For example, like SS overlapping. One s orbital overlaps with another s orbital. One s orbital overlaps with another s orbital, like this. Such type of overlapping is known as sigma. It is always sigma. For example, like H2. We have two hydrogen and both contain s subshell. So one s of hydrogen overlap with another s of hydrogen to form sigma covalent compound, sigma bond. Clear? Next, sp overlapping. One s orbital overlaps with another p orbital. So sigma bond is formed. One s and one p. But in this overlapping, a plane perpendicular to the plane of overlapping is observed where the probability of finding electron is least. Where the probability of finding electron is least. Such plane is known as nodal plane. One s orbital overlaps to one p orbital, and in this overlapping, one plane is observed to the perpendicular to the plane of overlapping where the probability of finding electron is least, which is known as nodal plane. So in case of sp overlapping, we have one nodal plane. Clear? Example of such overlapping is like HCl. One s orbital of hydrogen overlapped with one p orbital of chlorine head on. So here is sigma bond is formed. Clear? Next is PP overlapping. Another example of sigma overlapping, PP overlapping. One p orbital overlaps with another p orbital, which is formed sigma bond. And in this overlapping, we have two nodal plane is observed, which are perpendicular to the plane of overlapping. Two nodal plane is observed. These are the nodal planes. So remember that in SS overlapping, no nodal plane is observed. In SP overlapping, one nodal plane is observed, which is the perpendicular to the plane of overlapping, and in PP overlapping, we have two nodal plane is observed, both are perpendicular to the plane of overlapping. For the example of PP overlapping, the molecule is Cl2. One p orbital of chlorine overlaps another p orbital of chlorine head to head. Such type of bond is called sigma bond, in which we have two nodal plane is observed. Clear? Now pi covalent bond is formed. Pi covalent bond. Second point, a second bond is pi covalent bond. Pi, when the overlapping of orbital is sidewise or lateral overlapping, then pi covalent bond is formed. Lateral overlapping or sidewise. Due to lateral overlapping of orbital like this, lateral overlapping. In case of S, pi is never formed, it is always sigma. We have only one possible overlapping in case of S subshell, which is head to head only. But in case of P, we have two possibility like this and like this. If the overlapping is like this, lateral or sidewise, then loop attached with two different sided or two different phases. So rotation is not possible in case of pi, but in case of sigma, when the loops attached only one sided, easily rotate. So sigma bond is free to rotate about its axis, but in case of pi, due to attraction of two sided, pi bond resists to rotation. So it is less stable as compared to sigma. Clear? Due to fixed position or resist to rotation, it is less stable as compared to sigma. One more thing, first overlapping of PP is always sigma, and further all overlappings are pi. In case of covalent bond formation, the first position is always sigma, first bond is always sigma. Further all bondings are pi. It means molecule prefers to sigma formation, while in case of formation of sigma, after overlapping, it is always pi. Is it clear? So pi covalent bond like p pi overlapping, p pi overlapping. First example, in which one p orbital overlaps with another p orbital like this. Loops are associated with two different sides. Here is pi bond is formed, and in this overlapping, one plane which is the perpendicular to the plane of overlapping, where the probability of finding electron is least, known as nodal plane. Clear? So in case of p pi overlapping, one nodal plane is observed, which is the perpendicular to the plane of overlapping. Similarly, one example of p pi like CO2. In case of CO2, one is sigma and left two are pi, and in case of pi, one p orbital of carbon overlap with another p orbital of oxygen. Clear? So here is pi bond is formed. Second one is p pi d pi. One p orbital overlap with another d orbital to form pi bond. but due to the loop of d subshell, no nodal plane is observed. No nodal plane is observed. For example, like SO2, 1d of S overlap to 1p of O, so it forms d pi p pi overlapping. Clear? In which no nodal plane is observed. So this is the way to find sigma and pi, and what is the difference between sigma bond and pi bond. So one more thing, first sharing, first bonding is always sigma, and further all bondings are pi. Clear? Now how will you calculate the total number of sigma and pi bond in the given compound? For example, if the compound is given like C4H4O4. Suppose this is the molecule and we want to calculate the total number of sigma and pi bond. One method, which is hit and trial or trial basis method, firstly draw the dot structure of C4H4O4 and then count the number of sigma as well as pi bond according to its dot structure. Clear? For example, if we want to draw the dot structure, here is all 4 carbon atoms, oxygens are 4, so by using carboxylic group, 2 carboxylic group, 4 oxygens are used, and here hydrogens are 4, so on placing 1 double bond and 2 hydrogens, this is the dot structure of C4H4O4. So according to given dot structure, we can easily count the number of sigma as well as pi. First sharing, it is always sigma, this one is also sigma. Here is double sharing, one is sigma and another is pi. First sharing is always sigma, further all sharings are pi. Here is sigma, here is also sigma, this one is sigma and left one is pi. Sigma, sigma, here is sigma, next one is pi, sigma as well as sigma. So total number of sigma bond in this molecule is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And number of pi bond in this molecule, which is 1, 2, 3. Clear? So this is the way to calculate the number of sigma and pi bond in a given molecule, based on purely dot structure of the molecule. But if the molecule is too large or more number of atoms, then to draw its dot structure is not possible instantly. So we have a method which is the mathematical procedure for dot structure to calculate the number of sigma bond, pi bond as well as lone pair are present in a given molecule. So with the help of some variable, we can easily calculate the number of sigma bonds, pi bonds and lone pairs. Clear? But this mathematical procedure is applicable only for those molecules which obeys octet rule. So in case of carbon and its compound, it is easily applied or openly applied to identify or to calculate the number of sigma and pi bond in the given molecule. But except carbon family or compounds, this method is not applicable, since if molecule is electron deficient as well as electron rich or doesn't obey octet, so result will be wrong. So one more point, the mathematical procedure which will be discussed in next class. The mathematical procedure is applicable for carbon and its compound. Basically the heavy molecules are with carbon family, so this is the more convenient method to calculate the number of sigma as well as pi bond in a given molecule. Clear? Now this such mathematical procedure will be discussed in next class. Thank you.